This week we're going to be talking about probability. So what are your chances?
Let's take a look at an example. In the Worcester Sparks football game, quarterback Joe Puccinelli completed 4 throws out of 6 completions. What's the probability he'll complete his next throw? That's something that coaches really do look at.
So remember a couple weeks ago on the counting possibilities worksheet, we looked at this specific problem, the corn seeds probability.
For his garden, Clay has a mixture of 12 white corn seeds,
24 yellow corn seeds,
and 16 bicolor seeds.
If he reaches for a seed without looking, what is the probability that Clay will plant a bicolor corn seed first?
Okay, so let's look at some things about probability. Probability is the number of ways that an event can happen divided by all the possible outcomes. Going back to the corn seed problem, remember we had these conditions, so we know
we have 12 white ones, 24 yellow ones, 16 bicolor seeds, for a total of 52 seeds. There are 16 bicolor seeds, so the probability of choosing a bicolor is 16 out of 52, and always reduce, so it is 4 over 13.
Okay, so some common vocabulary that you probably need to know.
Outcome, a possible result of an experiment.
Event, that's an outcome or a collection of outcomes, such as rolling an odd number.
Sample space, the set of all possible outcomes.
Now think back to the corn problem. Our outcome was all those different corn seeds we had, 52 of them.
Our event was picking a seed.
And our sample space is all those different seeds in the bag.
There are a couple of things that you need to remember about probability. It's the measure of the likelihood or chance that an event will occur.
It's a number from 0 to 1.
0 means no likelihood of the event occurring.
And 1 means for sure that thing's going to happen.
And it can also be expressed as a decimal, a fraction, or a percent.
Now, we have 2 kinds of probability. The first kind is experimental probability. If you look on your handout, you have 2 boxes. You're in the left box. Experimental probability is in relation to an actual event, an experiment that happened. So you're using data that you have collected.
So for example, if a die was thrown 25 times, the number 4 was rolled 6 times. So the experimental probability of rolling a 4 is 6 out of 25. Can we reduce this? Not in this case.
But remember to always check, because you need to be able to reduce those fractions.
The other type is theoretical probability. This isn't done on an experiment. It's what should occur if we were going to do it.
So take an actual die, and what would be the theoretical probability that we could roll a 4? Well, there's 1 4 on that 6-sided die, and there are 6 possible outcomes, so the probability is 1 out of 6, theoretically. Notice that our experimental probability and our theoretical probability weren't the same, and that's okay because the experimental probability happened from an actual occurrence.
We also need to take a look at compound events. For example, you have a spinner with 6 divisions marked 1 through 6. What's the theoretical probability you spin a 2 and then either a 4 or a 5?
Now, this one requires that you look at a couple of different parts. You need to start by asking yourself, what's the probability that I spin a 2? And since there's 1 2 on a 6-spinner division, it's going to be 1 out of 6.
You also need to look at the probability of getting a 4 or a 5. Since 4 shows up once and a 5 shows up once, you have 2 options. So you have a probability of 2/6.
Compound events need to be multiplied. So the probability of getting a 2 and then a 4 or a 5, because these are independent events, is 1/6. That was the probability of getting the 2. times 2/6, that was the probability of getting the 4 or the 5.
So we have 1/6 times 2/6 to give us 2 over 36. Can we reduce?
Yeah, I think we can in this case.
I think we can.
Here's another example of probability. There are 7 students in a club, 3 girls and 4 boys. 2 students are randomly chosen to sing karaoke at the school talent night. What's the probability that both students are boys?
So the probability of choosing the first boy is 4 out of 7. There are 4 boys and 7 students. For the second boy, we are now left with 3 boys and 6 students. So we're going to multiply 4/7 times 3/6.
Hey, you know what? I don't know how to multiply those fractions.
So you need to multiply the numerators and multiply the denominators straight across.
And then how did you get from 12/42 to 2/7?
I had to reduce.
Our last topic is odds. Odds are a little bit different in probability because we can talk about the odds in favor of an event and an odds against an event. In favor of an event, you want to take the ratio of the number of favorable outcomes to the number of unfavorable outcomes. Notice we're not taking total this time. For odds against, we reverse that. We take the number of unfavorable outcomes divided by the number of favorable outcomes.
So going back to the dice problem and rolling a 4. So the odds in favor of rolling a 4 is 1 to 5 or 1/5.
But the odds against rolling a 4 are 5 to 1 or 5/1. Okay, well, that's it for today. We have some practice problems for you. Probability is a topic that you'll see fairly frequently on the proficiency test, so it's important that you take time now to practice it. Got any last words, Miss Gratz?
No last words. Good luck.
Bye.